All right, y'all. So what we're doing here is we're coming up for the linear equation, which in this case is going to be slope-intercept form. All right. Now, how we do that depends upon what information we're given. So not every single type of problem requires the same exact procedures. So if you see this first one we're given, negative 1/3 as the slope, and we're told the y-intercept, but we're given the y-intercept as a pair of coordinates. Okay, so for this first problem, that's what we're at. All right, now I'm going to ask a random question. Now I gave you the intercept as coordinates, and I told you that was the y-intercept, but I didn't really have to tell you that. I could have just given you those coordinates. Looking at these coordinates, how do we know that's the y-intercept? Looking at these pair of coordinates, how do we know that's the y-intercept? Okay, Aiden, how do you know this is the y-intercept looking at these coordinates? Aiden?
Yeah, I'm really not sure.
Okay, so what's the first number here?
0.
That's how you know.
Okay. All right.
So when x is 0, that means you're on the y-axis, right? So here's our y-axis. Again, line goes up and down. The y goes up and down. X would be 0 here. So if you're on the y-axis, you'd have to put 0 as the first coordinate because x is 0 there.
Okay.
So we don't have to do anything. We already know the number we could use for b. The number we could use for b is 5, because when y equals 5, it's because 0 was x. So this becomes 0 plus 5. All right, so now we can write y equals negative 1/3 x plus 5, and we're done. Now, the second problem, we're given different information. The second problem, we're given the slope, so that's good. But what we're given as coordinates is not the y-intercept, because x is not 0. This is not on the y-axis. This is some point located where the y's are negative and the x's are positive, right? So that would be below and to the right side of the coordinate system, right? That point would be over here. Okay, so what we got to do now is we got to set up the problem. So we'll start our rule, but the rule is going to be incomplete because we don't know what this other number is. Y is going to equal that other number when x is 0, and we don't know what that is right now. So what we're going to do next is we're going to replace the y and x with the numbers we're given in the coordinates and then find out what b is. So I'm going to replace the y with negative 2 and the x with 5. Again, I'm putting that as a fraction. If you want to put the 5/1 in parentheses to substitute for the x, you don't have to do that, but if that's helpful, that's one way you could think about it. Now, again, when you multiply fractions, put a 1 under the whole number, right? And then you'll be able to simplify because the denominator divided by is 5. Okay, now we have negative 2 equals 2 plus b. All right, so this is going to have to be negative 4. We're going to have to minus 4 here to make that work. So b is negative 4. Now, you could also minus 2 from both sides if that works for you. You'll still be able to get the solution. So now we know the complete rule. The complete rule would be y equals 2/5 x minus 4. And now we're done. Yeah, Tommy, you're right. Because it's always alphabetical, X comma Y. Always alphabetical. That's one way to remember. I don't know if that's why they did that. That's probably why. Humans like to have order. You know, if you create order out of chaos, it's more calming and soothing, right? Okay, so now we got the next problem. Now, the next problem, we're not given the slope at all. And the only thing we know is that wherever this line is, it crossed these 2 points. So that means we put 2 dots on the coordinate system and connect the dots. That's a line. But these 2 dots would be over here somewhere. You know, so we don't know what the y-intercept is. And we don't have a slope, but one way you could do this is put this on a graph and then use the slope triangle. That's possible, you could do that, but that's going to take a little more work. So let's instead use the formula to find the slope and then do the same thing, find out what the b is. What would y equal when x is 0 in our rule? Okay, so I'm going to go ahead and group the y's and group the x's. All right, so you could do right minus left. So the second y minus the first y over the second x minus the first x. All right, so 10 minus 5 on top, 10 minus 8 on bottom. And so now we have our slope, 5 over 2. So now we can begin our rule. It's still going to be incomplete because we haven't found the b yet, right? So when x is 0, y equals that other number. We don't know what that other number we call b is just yet. So what do? Well, we got to find an xy pair. Now you can pick either one of these. I would probably pick this one, the 8, 5, because those are smaller numbers. And generally, using smaller numbers are easier. So that's why I'm going to pick 8, 5. So I'm going to replace the x with 8 and the y with 5. Okay. And now we'll be able to simplify. Now, again, when you multiply by a whole number, you want to put a 1 under the whole number so you can multiply the fraction. Okay. And again, this makes it a little more visually pleasing. But if you multiply fractions, you multiply the top numbers, you multiply the bottom numbers, and then you divide. So 40 divided by 2. If you want to simplify, you can do that too. So 2 goes into 2 once, 2 goes into 8 4 times. So notice you get 5 times 4. So however you get there, you're going to wind up with 5 equals 20 plus b. Okay, so now this is going to have to be minus 15 to make this work. All right, now you can see that here. If you want to subtract 20 from both sides, you'll still get there. But again, if we're just using this procedure to find b, that's our goal, right? Because really what we want to do is create the slope-intercept form. Right now, we only have an incomplete rule. When x is 0, it looks like that's going to have to be minus 15. So now we have our complete rule. Okay. So this would be the equation of the line that crosses these 2 points, and we can see it's going to cross the y-axis on the lower side of the y-axis, way down there at negative 15. Okay, let me take a sip of water. All right, Charles, so we've got the last problem. Now, we've been looking at these tables for a little while now, but if we have a table, then the best procedure to use would be to use the table to get the rate of change. And sometimes we can use the rate of change to complete the table, get some more coordinates. And if we can use the rate of change to find the y-intercept, that would be very helpful. Okay, so looking at this table, we're going to first decide what's the rate of change. What are you doing to the x's as you go to the right? What are you doing to the y's as you go to the right? Okay, and I'm just going to write a partial version of the table I created for y'all because we only need to look at some of it. So I just didn't include the 15, 9, okay? So as you're going to the right, we're calling some random people. Again, so I'm using my random person picker, so that way it's fair, okay? All right, I don't think she's here today. Yeah, let's see her. Oh yeah, she's. Okay, so Jade, what are we doing to the x's as we go to the right? Jade, what are we doing to the x's as we go to the right?